Which is the best nuclear fuel cycle that meets public needs? Fast or thermal reactors, lithium-based salt or chloride-based salts, thorium-based fuel or uranium/plutonium-based fuels?
Robin says thermal.
Everything depends on what you're trying to achieve. I think the question is loaded, but in and of itself, there's no real better option. The question is, what are you gunning for? And I know that Elysium, none of us were actually pro molten-salt reactor specifically. We were just looking at constraints as they were: proliferation resistance, passive safety, and the ability to reuse nuclear waste as priority in the design. And we felt that going for a fast chloride molten-salt reactor satisfied those requirements in a more economic manner. But it really depends what you're trying to achieve.
100% agree with Carl. It's all about the niche you're trying to fill.
The fluoride is a little bit more of a known technology. So in terms of timelines, right, it's a little bit of a risk reduction. And it, of course, has its drawbacks, right? So enriching lithium, just like enriching chlorine, has a cost. The corrosion mechanics are more well understood, right? So the reduction potential and maintaining it, there are known pathways. If you look at your timeline and ease of entry, it's just a little bit lower risk.
I'll just add and echo what Jeff and Carl and Brandon have said. It is particular to the reactor developer's own business purpose. And in our case, it's economics. It's the cost of electrical power produced, or the cost of a BTU of industrial heat produced. Every developer has a different path, and that's okay. I think multiple developers are going to get there, which is going to be good for the public, which I think the context was the public.
I haven't heard any of the developers talk about online salt processing, removal of protactinium or anything like that.
Flibe Energy's working on that technology right now.
We certainly considered it. I mean, it was, TerraPower, when it first started, looked at molten salt reactors and actually dismissed them at the time in 2006, 2007, because they didn't like the processing and the proliferation and safeguard story. And it wasn't until we looked at it again in 2012 that we came upon, hey, we should be doing this fast, and we can actually make some of those issues go away. And not to say we don't get other issues, but, like others have said, each reactor developer has a set of trades.
I think all of us know, likely everybody in the audience knows, that when you are removing the liquid fuel and doing something to it outside the reactor itself, that's another processing facility, effectively. It's not really a simple purification system like you might have on a light water reactor. That's an entirely new added on facility. And I'll echo Jeff's words. Our intention is a commercial reactor producing electrical power. If we have to add on that additional facility, we put ourselves out of the market. We can't do that. So our design excludes that type of processing for our particular plant. As you said, Joanna, maybe next time, maybe in something in the future, maybe that's the answer. But
that may be how it turned out for you, Robin, but it's not an entirely separate facility for us. In fact, it's completely integrated within containment. It's much smaller than the reactor vessel. So our whole approach is designed around simplifying the chemical processing system. We've made hard choices to make that possible, that address each of these concerns. So yeah, for your reactor, it would be a totally separate facility, but it's not for ours.
I think that's also one of the reasons why we at Elysium went over on the chloride salts. Just one thing to notice is I think the trade-off is largely going to be driven around the regulatory requirements for whether that facility is a separate facility or if it's on-site. And actually, we're doing some pretty good work with the NEI Recycling for Advanced Reactor Fuel working group, but specifically its subgroup that treats how to build out a regulatory guidance document to actually have these facilities properly licensed, or at least new rulemaking around processing, reprocessing, recycling technologies. We're redoing the nomenclature. So there's a lot of groundwork that needs to take place, and I would welcome all members of the community actually to help in building out that reg guidance. But I think that just, after our first session in the summer, we went through the different guidance requirements, and aside from Appendix in Part 50, where they require a plan to send out some of our fission product waste forms over to a federal repository, that's where we're going to have to most likely apply for non-applicability. But otherwise, frankly, the process is pretty straightforward. It's really about showing that you're safe and limiting fission product release.
There are people, certainly in the DOE community, who are interested in this very topic. Kairos seems to be the only company presented here that is targeting solid fuel rather than dissolved fuel. Why did the others make this choice for dissolved fuel? It seems from the lunchtime presentation yesterday about decommissioning the MSRE site that liquid fuels pose a major safety/decommissioning challenge compared to solid fuels.
I think it again comes down to each company's goals. We looked at the fuel fabrication, the fuel qualification issues, the cost of the fuel, the back end of the fuel cycle, and TRISO just doesn't make sense to us.
I alluded in my presentation to MSRE not being in the best shape. That demo unit was not targeted for decommissioning, right? It wasn't designed in a way that was amenable to that. So we could be a little less strict and acknowledge that obviously when we're designing our reactors, we're thinking about decommissioning at the front end. I mean, Terrestrial was just talking about how it's going to be replacing its units every 7 years. So it's well thought out. I believe we all anticipate the difficulties in having to replace all these cores.
The use of a liquid fuel simplifies the cool portion of the reactor safety principles. Is you move the heat via the fuel to the mechanism by which you're cooling it. Doesn't require an additional system or systems or water cooling to cool the reactor. So it simplifies the cool function of cool, contain, and control. But then there's the economic reasons that Jeff alluded to as well.
Yes. I'll just mention that elegance has a cost. The cost is the extraordinarily complex thermochemistry the chemist even admitted was very, very hard. You're going to spend the money somewhere. Nothing's free.
The MSRE challenges. Big part of that was that they didn't do what Oak Ridge engineers wanted to do of removing the uranium right after they shut down the reactor. They didn't design the system to have the uranium stored there, and the engineers were pushed. Could we just reheat it up once a year? And it turned out they thought they could and they couldn't. And that's what created such a problem. It's pretty unique to the MSRE experience. It's not something I expect to see in any of the commercial units.
I hope that they don't do anything irreversible at the MSRE, because we sure would like to get our hands on that salt and make a real demonstration of our chemical processing system. It's a perfect test for us. It's the real thing with real fission products, and give us a couple more years and we'll be ready to go clean up the MSRE as part of our development.
I think it's really important that the United States has a portfolio of different molten-salt reactor options to appease different markets. And when you look at a lot of the international efforts, France, for example, they were working with Samofar on the molten-salt fast fluoride system, and they've switched over to chlorides. In Japan, you also have a similar program. And so having that diversity in coolant mix and fuel mix ensures that it's US-based vendors that are capturing this market share. US leadership in this domain is really going to be important, and having a portfolio of solutions is really what makes us better than a lot of these international programs. I know a lot of the times Elysium is associated with weapons-grade material for its commercial use. That is not the case. We're targeting SNF plus depleted uranium. Our core is sized for HALEU because our intention is to use HALEU, but again, because of the supply chain issues, we want to make sure that we can tap into a resource that is already there, which is SNF. But for the weapons-grade plutonium, that's only for the demonstration unit.
Luke Godfrey asked a very specific question about fuel and IMSR. I just wanted to answer it very quickly. Do you fill the new core with the full inventory of the previous one, and then what happens to the excess? So the short answer, Luke, if you're still listening, is no, we do not. We use a portion of that fuel. It's a significant portion. The remainder of that fuel coming out of the off-going core unit remains in the fuel storage tank within containment.
We are now past the time that Allison Hahn was supposed to be providing closing remarks. So why don't we go once around the horn, closing remarks, and then we'll let DOE provide the closing comments.
I saw someone write in the decade of MSRs, and I really think that's going to be the case. We really got to gain and just work off this momentum. I think a lot of the times we're talking about different fuel salts, different spectrums, and that tends to bog down the essence of what we're really trying to do, which is just reinvent nuclear for people like myself who were anti-nuclear. So exciting to be on the $1 billion panel. I'm so happy we can even say that about MSRs at this point. So I'm just excited to see where we'll be next year.
Thrilled to be here. Appreciate the opportunity and enjoyed the conversation. Really glad to see lots of pictures of hardware. I'm thinking maybe I'll have to try and have a side bet with Kairos. A case of salmon versus a case of Ghirardelli chocolate on which reactor goes critical first or something like that.
I think that's a fair bet. Just to see a new reactor in the United States go critical, it's been too long. Whoever accomplishes that, I wish them the best, because it's hard, right? We're not doing this because it's easy. We're doing this because it's hard. The passion that all of our companies have and the people that work there, it's great to see. because there's a lot of things you see today in the world and the news that can discourage you. But we're not the teams that are going to do that. We're looking forward and trying to make the world a better place. And I wish everybody the best.
We're all on a different path for different reasons, but at the end, we're all based on the same foundation of bringing a new, safer economic reactor to the commercial marketplace. That's what we're all here to do. We'll have varying degrees of success at different times along that timetable. It's good to see that everybody's still in the game. I don't know how many years ago we all started this. Brandon said this is hard work, and that's why we're doing it, and it needs to be done. And I just have to tell you, I've been at this over 40 years. I think this is the hardest I have ever worked. And I'm on the business side. I can only imagine how hard our engineers are working, our chemists are working. I'm on the business side, working with investors and working with shareholders. And it is hard work. We will get there. We will get there as an industry. And I firmly believe a molten salt reactor will be the first generation 4 reactor operating in North America beyond today's reactors. Absolutely believe.
All right. That was great. You guys were, thank you so much for informative and entertaining panel. And Dave, I will hand it over to you.
Allison, provide us our closing and give us the charge for Headed On.
On behalf of DOE, I want to thank everyone for participating in the annual MSR workshop, the Oak Ridge National Lab for hosting another successful MSR workshop, and I also want to thank David and Sandra and all the others working behind the scenes to enable the smooth execution of these annual workshops. Advanced reactors do have the potential to offer significant benefits: lower costs, enhanced safety and security, greater resource utilization, and simpler operating regimes, of course. Therefore, we see advanced reactors as being a very important part of the energy mix going forward to enable us to meet the administration's goal of net zero carbon emissions by 2050. And recognizing the importance of advanced reactors to meeting our climate change goals, reaffirming U.S. leaderships in nuclear energy and creating good paying jobs, NE is supporting the development and demonstration of advanced reactor designs through our ARDP program, that Advanced Reactor Demonstration Program. And you can see it in the NE's FY22 budget request. We clearly recognize the important role that advanced reactors can play in meeting our climate change goals and future energy needs, and the need for investments to deploy new technologies to market. So it's really encouraging to see this historic support for advanced reactors, including those MSRs. NE really does see MSRs as being a very important and innovative technology to help ensure that the U.S. has a diverse set of advanced reactor designs to meet the energy needs of the future. And with that, I just want to end by, again, thanking everyone for participating in this workshop, and hopefully we will see some of you in person at the hybrid workshop next year. Thank you.
All right. Goodbye, all.